Good morning to all. Myself Paras Mehta from BSc Chemistry Unit final year. Today's topic is organosulphur compound introduction. Sulfur is placed in the third period of the periodic table, just below oxygen in group 16. During the recent past, a lot of work has been carried out in the area of organosulphur compounds, primarily due to their importance in industry, pharmaceuticals, and metabolical process. Therefore, in this unit, we shall discuss some important aspect of the chemistry of organosulfur compounds. Structural features: both oxygen and sulfur alter the chemical nature of carbon atom due to which they are attached. But unlike oxygen analogues, in most of the sulfur compounds, the reactions occur by the attack of nucleophile, an electrophile, or even free radical at the sulfur atom. Another marked difference between oxygen and sulfur compound is that unlike oxygen which readily form double bonds, sulfur is reluctant to form double bonds by pp overlapping. Thus, with the expectation of the carbon disulfide thiocarbon compound R2C double bond S are quite unstable, readily undergo addition reaction. In other words, thioaldehydes are the most of the thioketones can generate only a transient intermediate that rapidly undergo dimerization and trimerization polymerization to form compounds having only sigma bond. The stability of thiocarbonyl compound is primarily due to the difference in the size of 2p orbitals of carbon and 3p orbitals of carbon, which makes 2p and 3p overlapping relatively ineffective. In addition to poor 2p 3p overlapping, sulfur is also reduced to form 3p 3p pi bond with other sulfur atom. It is because of these reasons that element sulfur does not exist at a diatomic s2 unlike O2 molecule. Instead, it prefers to form only SS sigma bond and exist as a non-polar protoatomic molecule acid having crown shape as shown in the figure. The angle is 107 degree. Non-polar 8-member ring structure of element sulfur. Further, due to the large size of sulfur atom, SS bond is quite long. As a result, the two 3p orbitals on each s atom cannot come close enough to undergo 3p 3p overlap to significant extent, and hence the pi bond between 3p 3p orbitals is very weak. It may, however, be noted that unlike thioaldehydes and thioketones, thioamides and thioacids are isolable and hence are relatively stable. This contradicts the generalization that pi bonds involving sulfur atoms are very weak. The actual reason for their stability is the resonance stabilization involving lone pairs of electrons on nitrogen or oxygen atom. Thiomates, thioacids. However, the contribution of structures again towards resonance hybrid of thiamides and that of structures for towards resonance hybrid of thioacid is significant because both of them have only single bonds between C and S. We have discussed above the sulfur has little tendency to form pi bonds through pp overlap. However, many sulfur compounds such as dimethyl sulfur acid, a widely used aporetic solvent having pi bonds between sulfur and oxygen atom. As anticipated, the double bond, like any other double bond, consists of a sigma bond and a pi bond. The sigma bond is formed by head or overlap between an sp3 orbital of sulfur and one of the half-filled p orbital of oxygen. Electronic configuration of s ground state 3s में 2 3p में 4 this में से 2 overlap है and 1 सिंगल है 3d में no element and electronic configuration of s first excited state 3s में 2 3p में 3 3d में 1 sp3 hybridization. The other two sp3 orbitals of s overlap with sp3 orbitals of two alkyl group to form two additional sigma bonds, while the fourth sp3 obtain a lone pair of electrons. Sulfur is now left with a half-filled d orbital, and oxygen also has half-filled p orbital. Hence, dxy lies in the plane of 2py orbital, and dzx lies in the plane of 2pz orbital. Therefore, d pi p pi overlap occurs between dxy and 2py orbitals to form a pi bond. In the valence bottom, the d pi p pi bonding implies that DMSO may be regarded as a resonance hybrid of the following contribution structure. Since DMSO has a high dipole moment 3.9 d, the suggests that structure 1 make a significant contribution toward the hybrid, which of course is much greater than the structure third. An important difference between ordinary double bonds with pi pi p pi p pi overlap sulfur oxygen double bond within p pi d pi overlap is that group attached to sulfur do not lie in a plane. That explain acetone is planar while DMSO is non-polar. Structures of thiols and thioethers. Both in thiols and thioethers, S in sp3 hybridization in the ground state, such as sp3 hybridized sulfur has two half-filled orbitals which overlap with the sp3 orbital of an alkaline group, and as a s orbital of the H atom as in thiols, or with sp3 orbitals of two alkyl group as in thioethers. Each of the remaining two sp3 orbitals contains a pair of electrons. However, due to great lone pair repulsion than bond pair repulsion, the CSH bond decrease from 109 degree 8 minutes to 100 degree in CH3SH. In contrast, in thioethers, due to great steric hindrance between two alkyl groups between an alkaline group and a hydrogen atom in thiols, the bond angle is thioethers is larger than the thiols. For example, methyl thioethers has a bond angle of 105 degree. Structure of sulfonic acid. In sulfonic acid, S is also sp3 hybridized. Since here we need to form two sulfur oxygen double bonds, therefore both 3s and 3p orbitals are promoted to d orbital as shown below. Second exciting state, in which 3s has one electron, 3p has one electron in each shell, 3d has two electron in two hybrid. The four sp3 orbitals of sulfur form 4 sigma bond, one with the carbon atom of the alkyne or the aryl group, and 3 with the oxygen atom. S is now left with the two unhybridized d orbital which overlap with p orbital of two oxygen atom to form 2 d pi p pi s double bond O bonds. The p orbital of the third oxygen atom overlap with s orbital of hydrogen to form an OH bond. Thus, sulfonic acids have tetrahedral structures. Nomenclature. For the purpose of nomenclature, sulfur compounds are classified according to the valent state of sulfur. The compounds contain bivalent sulfur are structurally analogous to the corresponding oxygen compounds such as alcohols, carbonyl compounds, carboxylic acids. Therefore, they are often named by adding prefix thio to the name of the corresponding oxygen analog. For example, RCH thioalcohol, C6H5SH thiophenol, C2H5S C2H5 diethyl thioether, NH2C double bond S NH2 thiourea. For naming the compounds having sulfur in place of carbon, the prefix thia is sometimes used. Thia thiacyclohexane 2,5 dithia 1,6 hexane diol. For compound having sulfur in the higher oxidation state, special name are used. CH3S double bond OH. Name is methane sulfinic acid. Benzene के ऊपर सल्फर अटैच्ड है, दो ऑक्सीजन है with double bond and one OH. And name is benzene sulfonic acid. Thio or thioalcohols. Just as alcohols are alkali derivative of H2O, in the same way thioalcohols are alkali derivative of H2S. वाटर में से H निकलेगा एंड R पार्ट लग जाएगा, ROH. ये अल्कलाइन डेरिवेटिव है H2O का एंड इज सेम करेंगे हम हाइड्रोजन सल्फाइड के साथ, H आउट एंड प्लस RCH. Thus, the general formula of thioalcohols is RCH. In UPSC system, thioalcohols are called thiols. They are also called merceptans, mercurium, mercury, captains is catching, captains. Since they react with mercury ion to form insoluble mercury compound, the functional group of thioalcohols is SH. It is called sulfhydryl thiomospeto. A number of sulfur compounds are found in nature. For example, butane thiol is found in skunk, an American animal. Propane thiol occurs in onion. Allyl mashed butane and allyl disulfide occurs in garlic. Nomenclature of thiols. They are named according to the following system. Common names. In a common name, thiols are called mustang. The individual name of any thiol is then derived by adding the word mustang to the name of the alkaline group. IUPAC system. In the IUPAC system, thioalcohols are called thiols. Individual name of the thiols is then obtained by the adding suffix thiol to the name of the hydrocarbon containing the same number of carbon atom. In case of polyfunctional group, the thiol's name is a derivative of the principal functional group. It may be noted that OH group is assigned higher priority both in numbering and naming. Methods of formation. Here are the methods of formation of thiols, मतलब thioalcohols. Firstly, for alkaline halides. When alkaline halides are heated with a large excess of sodium or potassium hydrosulfide, thiols are formed. सोडियम हाइड्रोसल्फाइड है, इन द प्रेजेंस ऑफ एल्कलाइन हेलाइड्स हम इसको हीट करेंगे, देन वी कैन easily get alkaline thiols. For example, पोटाशियम हाइड्रोजन सल्फाइड रिएक्ट करेगा CH3CH2I एंड आफ्टर हीटिंग इथेन थायोल हमें मिल जाएगा. सेकेंड इज फ्रॉम सोडियम एल्कलाइन सल्फेट, और when sodium alkyl sulfate is heated with sodium hydrogen sulfate. When sodium alkyl sulfate heated with sodium hydrogen sulfide, thiols बन जाएंगे. हीट कर दिया दोनों को, thiols बन जाएंगे like CH3CH. It's a thiol. From alcohols, substances are prepared from alcohols either by treating with phosphorus pentasulfide or by passing a mixture of hydrogen sulfide and alcohol vapors over thiourea catalyst at 673 Kelvin temperature. ROH with HCH हीट करेंगे THO2 at 673 डिग्री टेम्परेचर पे, तो RCH में thiols मिल जाएंगे. From alkyls, addition of hydrogen sulfide to the carbon double bond of an alkene in the presence of nickel sulfate as a catalyst leads to the formation of thiols. Alkene है, इसको हम हीट करेंगे. alkene है यहाँ पे RCH double bond CH2 हीट करेंगे HCH in the presence of nickel sulfate at 573 degree temperature Kelvin temperature, तो RCH SHCH3 to alkene thiol बन जाएगा. From thiourea or S alkaline isothiol uranium salts. When alkaline bromide or iodides are treated with thiourea as alkaline isothioureum salts are produced. These, upon unlike hydrolysis, gives thiols in about 18-96% yield. This is the best method of preparing thiols. The reaction of Grignard reagent with sulfur powder addition product which upon hydrolysis gives thiols. Grignard reagent MgX इसको hit करेंगे सल्फर के साथ सल्फर पाउडर के साथ then we can is found additional product RSMgX and फिर then we use water and H positive ion then we easily found thiol. Now it's time to read the physical properties. Physical property, physical state, smell, etc. Methane thiol is a gas while other thiols are colorless, volatile liquids with disagreeable smells. The lower members have extremely strong smell while higher members have mild odor. The odor of freshly cut onion is due to propane 1 thiol and that of garlic is partly due to prop 2 in 1 thiol CH2 double bond CH single bond CH2 single bond CH. Small quantities of ethane thiol are added to LPG to warn against leakage of gas. Boiling point due to the absence of hydrogen bonding. The boiling points of lower thioalcohols have lower than those of corresponding alcohols. However, thiols having 8 or more carbon atoms have slightly higher boiling point than corresponding alcohols due to stronger van der Waals forces of attraction and weaker H bonds. Solubility. Thiols are less soluble in water than corresponding alcohols. This is due to the reason that thiols cannot form H bonds with water. Dipole moment due to small electronegative of H than O. SH is very less polar than OH bond. As a result, thioalcohols have lower dipole moments have their corresponding alcohols. Next is chemical reaction. Thiols reassemble alcohol in many ways. Thus, main difference in behavior is towards oxidizing agent. Some important chemical reaction of thiols are discussed given below. Acidic nature. Thioalcohols are stronger acidic than alcohol. pK value of CH2 C2H5SH is 10.5 while the C2H5OH is 15.5. This is because of the following two reasons. The bond dissociation energy of CH bond is much lower than the OH bond. As a result, CH bond is cleavage more easily than the OH bond. Second is the anion left after the removal of proton RSH negative has a negative charge on S atom while in case of alcohol RO negative it is oxygen because of the large size of the sulfur RS can accumulate the negative charge more easily than the smaller size oxygen atom in the RO ion. Some important reaction of thiols due to their acidic nature are discussed below. Reaction with alkalines due to the stronger acidic nature they dissolve in NaOH or KOH forming their corresponding salts called mercaptized. The reaction is reversible and the mercaptized are completely hydrolyzed by water in the absence of alkali RSH NOH and the result form is RSNA positive plus H2O. Reaction with mercury oxide being acidic thiols react with mercury oxide to form mercury RSH plus HGO RS2HG plus H2O. Action of heavy metal salt. When a thiol is treated with aqueous solution of the salt of a heavy metal, lead acetate square is obtained. RSH PV bracket OOCCH3 cut twice, whole twice, and the reaction product is lead mercaptide. Rs twice Pb plus CH3COH. These heavy metals mercaptized are generally covalent compound. Reaction of carboxylic acid. Thiols react with carboxylic acid probably in the presence of an inorganic acid as catalyst to form corresponding thioesters. Acid acid ले लिया हमने R C डबल बॉन्ड O OH, thiol H S R H positive R C double bond O S R plus H2 thioester. Here we can easily found thioesters. The equilibrium lies mainly to the left, however, a good yield of an ester is obtained if acid chloride is used instead of acid. Due to weaker SH bond, thiols can easily oxidize. The nature of the product, however, depends upon the nature of oxidizing agent. With mild oxidizing agents such as air, H2O2, Cu, Cl2, or sodium hypochlorite, thiols are oxidized to dialkyl sulfide RSH plus H2O2 dialkyl sulfide RSSR2H2O, and then is reduction. Sorry, उससे पहले है. This give us an important point of difference between thiols and alcohols in the behavior of towards oxidation. Whereas alcohol oxidation increase the oxidation state of carbon, while in case of thiols oxidation state of sulfur increases. Reduction. On treatment with Rani nickel, thiols rarely undergo desulfurization to form corresponding hydrocarbons. रेनी निकल के साथ हम इनकी रिएक्शन करेंगे तो आर एच बन जाएगा आर सी एच सॉरी आर एस एच रेनी निकल आर एच प्लस एन आई एस. Action of aldehyde and ketone. Thiols readily combine with aldehyde ketones and ketones in the presence of hydrochloric acid to form thioesters or thioketals respectively. For example, aldehyde plus ethane thiol as in the presence of HCl form a thioacetal CH3CH S CH2CH3 whole twice plus H2O. Acetone plus SH CH2CH3 इथेन थायोल HCl की प्रेजेंस में रिएक्शन होगी. डाई इथाइल डाई मिथाइल मरकैप्टोन CH3CH3 SCH2CH3 SCH2CH3 plus H2O. Thioethers. Thioethers may be regarded either as dialkali derivatives of H2S or alkali derivatives of thioalcohols. They may also be regarded as derivatives of ether in which oxygen has been replaced by sulfur. Diethyl ether CH3CH2O CH2CH3. Reaction proceed. Diethyl thioethers formed CH3CH2 as CH2CH3. Method of preparation. By heating potassium sulfide with an alkaline halide potassium alkaline sulfate or potassium thiosulfate. Potassium sulfide alkaline halide K plus whole twice H2 negative plus RX KX निकल जाएंगे RS नेगेटिव X पॉजिटिव. रिएक्शन होगी RX RSR थायो ईथर फॉर्म हो जाएंगे. एग्जाम्पल देखेंगे K2S प्लस alkaline diacylate CH3 benzene SO3R and then form thioethers. These yields are generally good to fair good. By heating an ether with potassium pentasulfide ether ROR P2S5 हीट करेंगे थायोethers मिल जाएंगे RSR P2O5. These yields are often poor. By passing thiol over a mixture of heating alumina and zinc sulfide at 573 thiol RSH zinc sulfide plus Al2O3 573 Kelvin thioethers RSR plus H2S by addition of a thiol to an alkene in the presence of peroxide. peroxide को हीट करेंगे, देन वी उसका मैकेनिज्म फॉलो होगा, देन एल्कीन एंटी मार्कोनिक एडिशन होगा जब हम रिएक्शन करेंगे R2S डॉट प्लस R1 एल्कीन के साथ, R1CH2SR2 रिएक्शन प्रोसीड करेगी R2SH R1CH2CH2SR2 thioethers formed. Physical properties: thioethers are colorless, oily liquids having unpleasant smell. Solubility: they are insoluble in water but soluble in organic solvents such as alcohols, ether, etc. Boiling point: in generally their boiling point are relativity higher than those of the corresponding ether. This is due to stronger van der Waals force of attraction in the thioethers as compared to ethers, primarily due to bigger size of sulfur than oxygen atom. Chemical reaction: although ethers are relatively unreactive, thioethers are quite reactive. Their reactivity is primarily due to the ability of divalent sulfur atom to get converted into potash into compounds with +4 and +6 oxidation state. The main difference lies in the formation of sulfoxide and sulfones on oxidation and to form sulfonium salt with alkaline halides. Some of the important chemical reactions are described below. Weak basic character. Due to the presence of lone pair of electrons on the S atom, thioethers like ethers behave as a weak base. As such, they dissolve in 100% of H2SO4 to form sulfonium salt. R2S H2SO4 reaction proceed. R2SH positive SHO4 negative. Reaction with alkaline halides. Being sufficiently nucleophilic, thioethers react with alkaline halides by SN2 mechanism to form trialkyl sulfonium salt RSR plus R positive X negative, and the product is R S positive R double dash or single dash bracketable X negative. Next is formation of sulfur eel and their reaction. The sulfonium salts on treating with a strong base such as but lithium eliminated an alpha hydrogen to form dialkyl sulfonium methylides commonly known as sulfur eels. For example, dimethyl sulfates reaction करेंगे with the CH3I form हो जाएगा trimethyl sulfonium iodide CH33SI. Oxidation. Next is oxidation. Thioethers on oxidation first give sulfur oxide and then sulfones. Dialkyl sulfide RSR ऑक्सीडेशन करेंगे सल्फर ऑक्साइड बन जाएगा एंड दोबारा ऑक्सीडेशन करेंगे तो सल्फोन्स बच जाएगा. सल्फर ऑक्साइड में RSR S डबल बॉन्ड O RSR S डबल बॉन्ड O and S double bond O. Here are two oxygen in sulfones. With mild oxidizing agent HiO4 के साथ रिएक्शन होगी. डाईमिथाइल सल्फाइड की रिएक्शन करेंगे तो डाईमिथाइल सल्फोक्साइड बन जाएगा. With moderate strong oxidizing agent H2O2, then we form diethyl sulfones. Reduction. Alkyl sulfides on treating with Raney nickel readily undergo reduction and desulfurization form alkenes. R1SR2 plus Raney H2O Ni रिएक्शन प्रोसीड करेगी R1H R2H प्लस NiS. रिडक्शन हो जाएगा यहाँ पे. Reaction with bromine alkaline sulfide from many additional products. For example, addition of bromine gives dialkyl sulfide bromide R2S plus Br2 R2S Br2. Here are the reactions. All reactions of the basically here the reaction of thioethers. Thank you for listening. Thank you very much.